Classical probability is thought of as the very basic probability that we have, where we are looking at the probability that a certain event is going to occur given the sample space that the event is in. So we calculate that with a very simple equation, which says the probability of your event occurring is going to be the number of possible outcomes in that event versus the number of outcomes in S being your sample space. So, for example, if we think about a classroom, and let's say your classroom has 27 students in it. The 27 students would be the number of outcomes in the sample space. So this is kind of talking about your total. So you can think of that as like the total number that you have to work with. Whereas the number of possible outcomes for that example might be something like the number of female students in the class. And so let's say that there were 5 students in the class. Your question would be, what is the probability that in a class of 27 students you would have 5 females in that classroom? And so the number of outcomes in the event is going to be essentially the number of type or probability that you are looking for, the event that you're looking for. So here I'm going to use just a few examples of different situations where we are going to calculate that standard probability based on a specific setting. Now the first setting that we're looking at is we are looking at the ideas of a standard die or a standard dice. Now when we talk about standard dice, we are actually talking about the good old-fashioned D6 dice. And so here what that means is that your standard dice is always going to have the same sample space, and it's going to be that it has only 6 sides, and therefore its sample space would be 1, 2, 3, 4, 5, 6. Okay, so when we're talking about the total number, we're talking about 6. So here we have a couple different scenarios, and we're going to look at how each of these scenarios would work in terms of calculating probability. So the first scenario says, what is the probability that if you roll that dice, you're going to produce a number less than 3? So the first thing you have to do is you have to look at your event. And so in this case, my event here is going to be that x is less than 3. Okay, so that is the event that I'm looking for. And in this case, we have to look at our choices. And so the choices that we have here is that we have 1 and 2 are the only 2 numbers on a standard dice that are less than 3. So my choices would be 1 and 2, so that's going to give me 2 total choices. Now the other thing that we know is we know the number of outcomes in my sample space is going to be 6 because we're talking about that standard dice. So here we would set it up by saying the probability that x is less than 3 is going to be the number of choices in my event. So I have 2 possible options over the total number of options we had. So here, once we have 2 over 6, okay, we can do a couple things. One, you can reduce that fraction to being 1 over 3. The second is you have to pay very close attention to the wordings of your problems. And so in this case, we have that you need to round your answers to the nearest millionth. Now the part that says when necessary, what that's talking about is what happens in your calculator when you do your division. So if we take just a standard calculator, much like this one, okay, just a standard scientific calculator, if I do 1 divided by 3 and hit enter, notice I get this big long decimal. So what we want to do is we want to write that big long decimal just out to the millionth place. So here we would say that my probability is 0.333333, because millionth means 6 places. Okay, so here we're showing a lot more than 6, but we only need to use 6 of them. Now, the next probability we're going to look at says find the probability that the number rolled is even. So in this case, when we're thinking about your event, our event here is even. So when we talk about your choices here, and notice I always like to list them, my choices here would be 2, 4, and 6, which gives me a total of 3 options. Now, the other thing we still know is that the number of outcomes in my sample space is still going to be 6. So the probability that we end up with an even number is going to be 3 options out of my 6 total options. Now, when I reduce this, I end up coming down to 1/2, which, if we do in our calculator, will give you 0.5. Now, one of the things that you need to notice is that I'm not putting a bunch of zeros on the end. So this is a finite decimal. It means it has an ending point. It stops. 0.5 is it. So when we're writing out these probabilities, the when necessary piece comes into play only when you have a decimal that extends beyond your millionth place. Okay, if your decimal cuts off early, all you're going to do is write the decimal you see and all of it. Okay. Now the last one says find the probability that the number rolled is greater than 0. So in this case, my event, just like before, is where we're looking at x being greater than 0. Well, in this case, my choices here in terms of my dice would be 1, 2, 3, 4, 5, and 6. So my total choices are 6. Now, just like before, my number of outcomes is still that standard dice. So it is still 6 outcomes. So for this problem, the probability that my x is greater than 0 is going to be my number of choices, so 6, over my total options, 6, which in this case is going to give me a probability of 1. Okay, and so that's where we would stop. Now, with classical probabilities, the biggest thing you have to remember is that your probability is always going to be less than or equal to 1. Okay, that's one of the things that makes probability or classical probability easy or fun to work with, is that your decimal is always going to be between 0 and 1. It's never going to be negative, but it's never going to be bigger than that. Okay. Alright, so let's look at a different example here. So here we're talking about a roulette wheel. Now, when we're looking at a roulette wheel, there's a couple things that we have to keep in mind. First is the makeup of the roulette wheel. So we have 18 red pockets, we have 18 black pockets, and we have 2 green pockets. So that's what makes up your wheel. And when you're spinning the roulette wheel, it's all about probabilities. And you're looking at the probability that your ball is going to land in a specific place. So here, this question wants to know the probability of landing in a red pocket. So the first thing we need to know is we need to know what is our event. And in this case, our event is going to equal your red pocket, which we already know there are 18 of those. Now, the other piece is that we have to know the number of outcomes in your sample space, which is the same as your total. Well, in this case, my total is going to come from my red pockets plus my black pockets plus my green ones. So here we know that I have 18 red pockets, I have 18 black pockets, and I have 2 green pockets. This is going to give me a total of 38 pockets, okay, on the wheel. So here we want to set up our probability. Here my probability is that we're going to land on red. So that is going to be the event. So I have 18 options to land on red. I have 38 total pockets on my wheel. So in this case, what we would do is we would take, again, our calculator here, so kind of like this one, and we would simply do 18 divided by 38, and notice I have a big long decimal, and so we want the millionth place. So my probability is going to be 0.473684. Now when you get out to the 6th place, you're going to look at the 7th place and you're going to then round accordingly. Okay, so you're going to count out 6, use that 7th place to help you round. In this case, my 7th spot is a 2, so the 4 stays. And that would be the probability of landing on a red pocket. Alright, let's look at a different scenario here. So we have the probability that a card drawn randomly from a standard deck of cards will be an ace. So the first thing that we need to know is we need to know a little bit of information about a standard deck of cards. So what do we know? Well, in a deck of cards, we know that we have 2 colors, and those colors are red and black. We also know that we have 4 types or suits, and those are going to be ace, hearts, spades, sorry, not ace, clubs, and diamonds. Now with that, we want aces, which is where that ace comes from. We want aces, and we know in each one of these types you're going to have an ace. So here, when we look at your event, my event is going to be aces, which we know there are 4 of. Now, my number of outcomes is going to be my total, which there are going to be 52 cards in a deck. Okay, so there, in order to find my probability that we're going to draw an ace, is going to be the number of aces in the deck versus the total number of cards in the deck. So then, just like before, you're going to take your calculator, and you're going to do 4 divided by 52, hit enter, and we're going to go out the 6 places. So this is 0.076923. And that would be your probability. Alright, let's spice it up a little more. So here we have that a book contains 321 pages, numbered 1, 2, 3, etc. If a student randomly opens the book, what is the probability that the page's number has all of its digits the same, ignoring single-digit page numbers? So the first thing we know is we know our total. Our total is the 321 pages. Now we need to create our event space. So our event space is going to be the page numbers where the digits are the same. So here, if we ignore your single digits, we have 11, 22, 33, 44, 55, 66, 77, 88, 99, 111, and then 222. So we want to know how many that is. So after you create your sample space, you would count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my event has a total number of 11. So here my probability would be labeled as the number of pages of the same digits. So that's the probability we're looking for. You do need to make sure when you're writing your probabilities out that you label them very detailedly and accordingly. And in this case, we would have 11 possibilities out of the 321 pages that there are. Again, you would use your calculator and you would come out with 0.034268. Okay? So again, remember, you want to make sure that your label inside your parentheses, so what you're trying to find the probability of, uses as much detail as possible so that your probability is really easy to understand. Okay? Let's look at this next one. Consider a parent with 4 biological children. Find the probability that all 4 siblings are boys. Okay? So here we know that my total is going to be 4 kids. And in this case, I want to know the probability that they're all boys. Well, before I get there, I need to know what the probability of having a boy is in general. Well, that would be 1/2. And the reason for that is because we only have 2 genders to choose from. So that also means that the probability of having a girl is 1/2. Okay, so when we're talking about our event, the event is picking a boy. So when we're doing this, what we have is we have 4 kids. So the probability that kid number 1 is a boy is 1/2. Well, that's going to be the same. The probability for kid number 2, so the probability that kid number 2 is a boy is also going to be 1/2. The probability that kid number 3 is a boy is going to be 1/2. And the probability that kid number 4 is a boy is going to be 1/2. So in this case, what we have is we have the probability that all 4 are boys is given by the number of the event over your total. So in this case, what's going to happen is we're going to have the probability is going to be that we have to kind of multiply all of these together. So my first kid would be 1/2. Well, times my second kid, which is 1/2, times my third, times my fourth. And in this case, this gives me the probability would be 1/16. Which is going to be 0.0625. Okay, so the probability that all 4 of my kids come out to being boys is 1/16, which is 0.0625. Alright, now the last one that I wanted to look at says, what if I have 2 standard dice rolled? What is the probability of the sum of the rolls equaling 8? Now there's a very fast way that you could go ahead and figure this out, and I like to do this by drawing a table. So the first thing we're going to do is we're going to draw across the top, and this is going to be my dice number 1. And my options are 1, 2, 3, 4, 5, and 6. Then we're going to go ahead and we're going to draw down. And this is going to be dice number 2. And here we've got 1, 2, 3, 4, 5, and 6. Now with this, I'm going to go ahead and input my lines here just to make it a little easier. So what I'm doing is I'm creating a table that's going to allow me to figure out what my probability is. So this is how easy this gets. So we're going to go ahead and I'm going to, oops, sorry about that. I'm going to fill in this table going vertically. So I started with a 1, so I'm going to just count up. So this goes 2, 3, 4, 5, 6, and 7. I'm going to come over here and I'm just going to start at 2 and count up. This is 3, 4, 5, 6, 7, and 8. Then this goes 3, 4, 5, 6, 7, 8, 9. This goes 4, 5, 6, 7, 8, 9, 10. 5, 6, 7, 8, 9, 10, 11. And then I have 6, 7, 8, 9, 10, 11, and 12. Okay. Now, if you look closely at my table, you can see 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and so on. So what we did is we created a table of addition. Now what we're looking at is we want to know when they sum right here that the rolls equal 8. So if you notice, I have this diagonal line right here. It shows up that all of these are 8. So those are my options that sum to 8. Okay. So here what we are looking at is we are looking at my number of combinations. Okay. So the number of times that you sum to 8 gives me 1, 2, 3, 4, 5 times. And then we have to look at your dice. So I have 2 dice. And in this case, I have 6 times 6 because each dice has 6 sides. So the way we set this up is we set this up as the number of times that you sum divided by dice 1 times dice 2. So in this case, what that's going to give us is that's going to give us the number of times we summed was 5 over 6 times 6. So when we look at the math here, this is going to give us 5 over 36. And again, we're looking for a probability. So just like before, we would take our calculator and we would do 5 divided by 36, hit enter, and that gives us the probability of 0.13. And then notice I have a bunch of 8s. So we would have 8, 8, 8, 9. So again, if we count out 6, 1, 2, 3, 4, 5, 6, we would look at the 7th one right here, which is an 8. 8 tells us round up, which is why that's a 9. So there you have it. You have 6 different examples, all dealing with classical probability. If you have any questions, please feel free to let me know. Otherwise, I do hope you enjoyed this video, and I'll see you next time.